Here in this video, we would like to talk about an arrangement called bimetallic strip to show correct time with a pendulum clock. So first of all, what's the problem with a pendulum clock? Let me discuss, right? So if I have a pendulum clock, it will have a long metallic rod to which a kind of a pendulum swing is arranged. It will be oscillating. With respect to the oscillation, the time of the watch is also moving. So this pendulum clock is having a certain length. It's made up of metal. As it is made up of the metal, with respect to temperature, that length increases, its time period increases, number of oscillations per second decreases. Therefore, the total time per day loses, as I have explained earlier. But we don't want this to happen, a loss or gain of the time with respect to variation of the temperature with a pendulum clock. Then that can be solved with a arrangement called something like bimetallic strip. So how do you arrange that? That pendulum rod will arrange in a combination of two metals as it is shown here. They are very thin. I have drawn only a thicker one to explain to you that how it works, right? So the same pendulum like what I have said here is drawn here in a magnified version here. But if you notice carefully, it is not made up of one metal, rather it is made up of two metals. That's why this is called as bimetallic strip. Bi means two, metallic means metals, strip means there are two metals are there arranged. How they were done is, one metal, say metal 1, is fixed on the top. That means what? If the temperature rises, the only way it can expand is it can expand downward direction. The other metal is fixed at the bottom, metal 2. Then if it has to expand, it expands in upward direction, right? So both the metals expands in opposite directions. So how do we do this system is, uh, if so this is a fixed kind of a system which is little variable, little movable. So as one expands downward, other expands upward, so that the total length remains constant. So it is possible only when increasing the length of the first rod in upward direction equal to the increase in the length of the second rod in the downward direction, so that the total length of the system remains constant. We know the formula definition of alpha as increase in the length, ratio of increase in the length to its original length per 1 degree centigrade rise in temperature. So delta L can be written like alpha L delta T. So in the place of delta L1, I can write alpha 1 L1 delta T. In the place of delta L2, I can write alpha 2 L2 delta T. Delta T is same for both of them. So the condition we have derived is alpha 1 L1 equal to alpha 2 L2, or alpha 1 by alpha 2 equal to L2 by L1, or alpha is inversely proportional to length. Thus, we arrange a combination of a system in such a way that wire with a higher alpha will have a lesser length, wire with a lower alpha will have a higher length, so that their combination of length and alpha always remains a constant, so that the total length of the system always remains a constant. So you arrange this kind of a bimetallic strip in a pendulum clock, so that what happens is, one goes up so that the length reduces, other comes down so that the red length increases. It is as much as it is reduced, as much as it is increased. This increase is compensated with the reduction, so that the total length of the system remains constant, so that the pendulum clock shows same time whatever may be the temperature is.
So I need not worry about the loss or gain of the time in a pendulum clock. This is how a bimetallic strip is used to fix the loss or gain of the time with a pendulum clock. That's it. Thank you for watching.